All right, you are now being recorded for all to hear. Okay. Today we're talking mostly about tangents and secant lines, and we're going to throw circumscribed, say that word carefully, angles in there as well. People laugh more or less. That's maybe still like processing. Okay. So we first need to decide what a tangent line is and what a secant line is. A tangent line is a line that just barely kisses the side of a circle. So I always try to draw in white after we've been on the whiteboard. So it's a line that crosses the circle at one point, so it just kind of skims to the side of it, and it's perpendicular to the radius. So looking at this picture, which line crosses the circle at just one little tiny point, skims the side? TR? And if you're going to name a line, it needs to have the two lines or the two arrows on top of it. So line TR is the tangent line. Any guesses what the point of tangency is? Raise your hand if you have an idea. What's the point of tangency? Let's go, Jason. Yeah, it's the point that it's talking about up here. Good. The point where the tangent line crosses the circle. Now I heard somebody say it. What point is the intersecting point over here? R. Good. The point where you name a point by just the capital letter. The last definition is what is a secant line. It's not drawn in, so let's add it. The secant line is ML. The definition, what would be the definition? A line that what? Keep talking. Crosses the circle at 2 points. So a secant line crosses a circle at 2 points. So it goes through the circle. Tangent lines skim the side of it, secant lines go through. Kind of like a chord, but it's been extended. All right. Now, if two lines are tangent to the same circle, so line AB is tangent. Well, if line AB is tangent, then what kind of angle is angle B? From the definition above, angle B has to be what kind of an angle, Everett? Ooh, that is the point of tangency, but how big is this angle that we've created? It's this word right here. Sarah, say it again. 90 degrees, good. Now if I made that into a triangle, this theorem has to do with this side and this side. How do they look? Like, relate them to each other. How do they look? They look equal. Is there a way that we can prove that they're equal? This is the radius, right? This is the hypotenuse of the right triangle. Is that okay? No volume, no. So if you have a right triangle, you know the radius, you know the hypotenuse. Is there a way that you could figure out the length of AB? What would you do? Everett? Ooh, good guess. We don't know any of the angles besides 90 though. The trig is a really good idea. What's the other tool that we have with a right triangle? The Pythagorean theorem. If you came up with either of those two ideas, trig, which was a good guess, or the Pythagorean theorem, give yourself a point. We're going to use the Pythagorean theorem, and we would get, so let's just plug in some numbers here just to guess. If this was 5, and this was 13, and you did the Pythagorean theorem, you would get that this side is 12. So our guess is that this side should be 12 as well, right? Yes? Because we said they look equal. So let's see if we can prove that. Okay, are we still dealing with a right triangle? And how do you know? Seju, you nodded your head. How do we know that this is a right angle? Yeah, because it's tangent, right? It's perpendicular. So we still have a right triangle. Do we know how long this side is? It's r, which would, in our case, for our example, is 5, right? Do we still know how long the hypotenuse is? This triangle seems to be exactly the same as this triangle, right? And if we did the Pythagorean theorem again using the 5 and the 13, would we still get the 12? Yeah? So we could use the idea that these are two right triangles to prove what this is going to say. It says if two lines are tangent to the same circle and originate from the same exterior point, then these two segments are what? Are the same. Then, let's call it AB, is congruent with AC, meaning their measurements are equal to each other. So if they're equal, then you can do a lot of problems with the idea that it's equal. If we didn't know that this was 12, and we know this was 12x and say, let me start over. This is 12 and this is 3x, could you solve for x? Yeah, x equals what? 4. If this was 12 and this was x minus 1, what would x equal? Close, 13. 13 minus 1. Alright, so yeah. Okay, let's move on. We're going to use this idea to find the perimeter of each polygon. So the outside, we're going to ignore the circle, but we're going to use that rule. And we want to assume that all lines that appear tangent are. So if this is tangent, that means this piece and this piece are the same. That means that this piece and this piece are the same. With me? That means this piece and this piece are the same. So how can we use that to find the perimeter of the whole triangle? We're going to do a seating chart change. If this is 5.5, what's this? Good. If this is 8, this is 8. If this is 5.5, this is? Okay, if in this problem you've spoken out loud, give yourself a point. Now you have all of those little pieces. So now what do? Add them all up. You should get a nice number like 38. Oh, like exactly 38. All right. This is the 4th time I've taught this lesson. All right, so let's do that again. This time, we don't know all of the little pieces. We know some holes. So what ideas do you have on this one? Can I show you, before you give me your idea, can I show you a major mistake that happens? Major mistake is splitting this in half. Are those two pieces equal? No. No, so don't split it in half. This is a good example over here to show when they're not equal. Could they be equal? Yes. Are they always equal? Not very often. Okay, Marcus, keep talking.
We should take 17.6 minus 3.3 side of this tangent, and then we have what the other part on that one has.
Okay, pause. Yes. I almost interrupted you just to be funny, but then I decided not to. This is 8.3. This has to be what? 8.3. So we're going to use Marcus's idea that this entire thing is 17.6. We've got to get rid of 8.3 of it. So what do we have left? 9.3. Now if that's 9.3, then this guy has to be what? 9.3. Which means we should be able to figure out this guy which would be
Perfect 11.
a perfect 11. And if that's 11, this booger's got to be 11 too. So now do you know all of your little pieces?
Yes.
Yeah. You can add, do you have to add the 11 and the 9.3, or can you just use the 20.3? Add that, add that, add that. You should have the entire perimeter. $57.2. Good. If you spoke out loud in that, probably give yourself a point. You stayed quiet, no points for you. All right, last one. Any ideas on this one? 57.2. Sorry. Wait, what? 58. Oh, is it 58? No, it's 57. I think it's 57. So you may have plugged something in a little bit wrong on your calculator. All right, what about part C? Ideas? Raise your hand if you have a thought. Part C. Elise. Yeah, these are both tangent, right? So they're equal to each other. This information in here is extra. You don't need to know that. If they were to tell you that the radius is 7, that is extra. You don't need to know that. But you know that this piece and this piece are both coming from the same exterior point, so they are equal to each other. Uh-huh. On your homework, it tells you what you're looking for, so it's possible it asks for the measure of AB or whatever, and then in that case you would plug it in. But for us, let's just find X. 4 equals 2x minus 4, and the 4, 8 equals 2x, so x equals 4. Good. Let's pause this. Don't forget to remind me to turn it back on. Let's move on. We are going to start just by drawing these two things, and then we're going to make up a rule. So if it is 2 secants, it looks something like this, right? If it is a secant and a tangent, it would look something, ooh, that was done. Something like this. And if you have 2 tangents, it would look something like this. Kind of. It's how the lines are hitting the circle. Now with each of these, you have, well not, with the 2 secants, you have these 2 arcs that are inside the circle, right? This one right here and this one right here. And then you have these 2 arcs that are outside the circle. We're not worried about the arcs on the outside, we only care about the ones on the inside. Okay? With the 2 secants, or the secant tangent, you have this arc inside the circle. We don't care about the one outside the circle. But with the 2 tangents, do we have any of the arcs that are outside the circle, or is the entire circle between the 2 lines? The entire circle is in between the 2 lines. Good. Now with all of these, you have a larger arc, right? And this one. And you have a smaller arc. On the 2 tangents alone, not the other 2, but because the entire circle is in between the 2 tangent lines, I can say that the big arc plus the little arc add up to be what? 360, because the entire circle is in between the lines. Is there a rule that we can put like this with the secant tangent or the 2 tangent? Or the 2 secant, I mean. No. Because in both of these cases you have a little bit that's hanging outside. Now we're going to make up a rule that has to do with finding this missing angle right here. And this missing angle right here. And this missing angle right here. The rule is that that angle, that exterior angle, sometimes is exterior, sometimes it lands on the circle. It'll never land inside the circle. But that angle right here is 1/2 of the big arc. So this is the big arc, this is the big arc, minus the little arc. Little arc, little arc. Yes.
Okay.
Yeah. So this angle right here, or this angle right here, or this angle right here, is 1/2 of the big arc minus the little arc. There it is, Sarah. So let's try a few of these. Now, really quick, just to note, if on this one, you only know that this is 100, is there any other information that you could figure out to help you solve this problem? Subtract it from 360, so this guy would be what? 260. Good. And then we could use that formula to figure out this angle. So we'll come back and we'll do that one in just a second.
No, we just need to find the big and little.
And then subtract and divide by 2. Okay, so let's try part A. On this one, you have the large arc. You have the little arc. We don't care about this one. What's the formula? If I want to find that missing angle, x equals 1/2 times what? The big minus the little. So then you have 1/2 times what? So 1/2 times 80, which is 40. What kind of answer is this? This one is the degree answer. That's when I put the degree. And that's it. This formula will not be provided for you on the test. You just need to know what it is and when to use it. So let's do another one. Part B. If I want to find this missing angle C, x equals 1/2 times the big arc, which is, the big arc is right here, 134, minus the little arc. However, on this problem, because this point is on this circle, there is no little arc, so we just subtract 0. And then we get 1/2 of 34, or 1/2 of 134, which is 7. This actually is an example of what we did on day 1. Because this is an inscribed angle. That is the arc, so it's half of the arc. It's using the same rules that we did on day 1. Let's do that again. Part C is also an example of 9.1. This is an inscribed angle, so it is half of the arc. There is no little angle, so it's a special case. Yeah, that's what we're doing. Just half this. Yeah. Nope. The test problems, though, should look a little bit more like this. I don't know if there will be anything on this. Try part D on your own. X equals 1/2 of the big angle, or big arc minus little arc. X equals 1/2 times what? 98, which is 49 degrees. Raise your hand if you got 49 degrees. Point. Good. All right, so what are we going to do on part E and part F when now we're using variables? Not just numbers, now it has algebra in it. What do we do? What's the formula? The formula is still the angle equals what? 1/2 of big minus little, right? Do we have different pieces that we could plug into this? Yes or no? Do we know what the angle is, or at least what the symbols are for the angle? This is my angle. This is my what? Big arc. This is the little arc. So let's plug that in. The angle, which is -3 plus 6x, equals 1/2 times the big arc, which is minus the little arc, this should be in parentheses, minus 45. In this case, the parentheses don't matter, but what if this was a binomial? What if it was like 45 plus x? Would the parentheses matter?
Yeah.
Because you would have to distribute, right? So maybe make a note. Let's not change the problem, but make a note that if this is a binomial, what does binomial mean? Has two pieces, two terms, right? If it's a binomial, we have to distribute the minus, the negative. There we go. Good. How do you solve this equation? Where would you start? Kind of ugly. First step? There's like 3 first steps. Do what? No? And before I distribute the half, I might combine like terms in the middle. But yeah, maybe you start there. So this would be 17x minus 1 minus 46 would be a minus what? Did I say minus 1 minus 46? I do that a lot. Minus 46. As I said, the answer is. Okay, so now you have negative 3 plus 6x equals 1/2 17x minus 46. The idea was to distribute the 1/2. Not the only way to solve it, but it will work. What's the other way? How else would we get rid of the 1/2? Times it over. We get times it by 2. But if we distribute, we get 1/2 times 17, 8.5. 8.5x minus 23. And now you just solve. So let's subtract the 6x. You get 2.5. Add the 23. You get 20. And now what? So x equals what? 8. So it's the same rules, a lot harder to solve because you've got a lot more algebra in the middle. Let's go ahead and what? Anybody else? Okay, let's do one more and then I think maybe we'll just push through and finish the next page. It's all a review. But let me finish the notes. Okay, this is the arc. This is the angle. So if we were to set it up, it's going to be the angle 42x plus 1 equals 1/2 of the big arc minus the little arc. Any questions with how we set up this equation? The angle, which actually ends up being on the circle this time, which is why there's no little arc, equals 1/2 of the big minus the little. Now, I think I want to solve this the other way. On this one, we distributed the 1/2. The other way to solve it is to multiply by 2. If you multiply both sides by 2, the 1/2 cancel and nothing in here changes. Is that okay?
No.
I kind of like 2 because dividing by 2 gives me decimals and I don't like to work with decimals. So if I'm multiplying the left by 2, what happens? 42 doubled is 84x plus 2 equals 85x. So then we do what? Subtract that 84x, which is convenient because then you're left with x equals 2. I believe on your homework it asks you to plug it back in and find missing pieces. So if it did, you would just plug it back in and you would get something.
Multiply it by 2, double it, yeah.
which is the same rule that we've already done, right? Using the interior angle, the inscribed angle idea from day one, we would just double this instead of equal to that. We've been doing it the whole time. Yeah. Okay, next page. These all should be review. We've been doing them since day one, so if you missed day one, here's a recap. For problem A, is this asking for a degree or is it asking for the length? So we need to know what that symbol means. Is that asking for a degree length or is that asking for a, sorry, is that asking for a degree or is that asking for a measurement, a length? All in favor of degree? Should we vote? All in favor of like the actual physical length? All in favor of degree? All in favor of length? Does it say the word length on there anywhere? And the problem does it say length? It is not asking for the length, it is asking for the degree. This is the degree required to make that arc. So, if this is the diameter, if it shows you a diameter, you almost always will use it. We're looking for this. You could find this little guy and then add those two together. Or, Marcus, you could do what? 180 is a semicircle. Subtract the piece that you know, and you have your answer, 124. Good. What about the next one? VSW. Try it. You have 30 seconds to get somewhere with it. We're trying to find VSW. That's not what you're trying to find. That little piece. Part B. VSW. All right, your last chance for tickets today. Any ideas for Part B? So, Sarah. Hold on. One more. 360. Do you know what you got for all of those? So you add all those together, you get 320. You know the whole thing's 360, so we subtract and we get what? 40. If you got 40 degrees, give yourself a point. Sarah, you get 2. Any questions with that one? Good. All right, what about, let's jump to part D. Part D. The 33 is angle W, yes. Okay, there's 2 ways that I can think of to do this. I need somebody to start me off. What would you do first? Britt, go ahead. Yeah, so you're looking for this arc first. I think this is probably the easier way to start. So if that's 33, this is 66. And I double it because this is an inscribed angle opens up to that arc. Okay, somebody else. Keep talking. What's the next step? Susanna?
Yeah, do you know that?
WY is the diameter. Good. Something.
You know that it's 180, so
And you get 114. Good. Britt, you get 2 points. Susanna, you get 2. Everybody else that got the 114, you can have 1. Okay. Good job. Next question. Let's do part C first. Then we'll do E. I think E's a little bit harder than C. So take 30 seconds, see if you can do it. Let me see if you have an idea where to start. Part C. I think soon we should plan some sort of celebration. So you gotta think of a reason to celebrate. And then we can plan some sort of celebration. Most of my classes, for one reason or another, have had some sort of, like, it's Pi Day, okay, you got Pi. Or yesterday I had a class that every single one of them passed, and not a single person came in and said, but can I please have an A? And I didn't have to say, no, I'm sorry. You got a B plus. Yeah. So everybody in that class did exactly what they were supposed to. If they were absent, they knew what they needed to do to fix it. Nobody kind of begged for their grades, so they got a root beer float party, which is why we have drinks over here, which I already offered to you, right? You can finish it off. This class hasn't, oh, that's right. This class hasn't had some sort of celebration, so we need to think of a reason to celebrate, bring in food, and we should celebrate. I know, so we need a celebration. That's what I'm saying. Trying to celebrate something. Okay, ideas on part C. Where do we start? Okay, Susanna, go first. Okay.
Is 184.
Okay.
Minus 74
To get this art. Okay.
Yeah, and that's 101. And then you do 360 minus
that.
And just to get that one over there, and that's 96. And then yeah, 96 is 101. To get the
Ooh, I think that there's a small mistake somewhere. You're really close and your idea is perfect. Although there is a slightly easier way to do it. So I want to show you the easier way so you can jump to the faster. It's not easier, faster. Same level of difficulty. So we did it a little bit different. This one, or this 92 actually is unnecessary. You don't need it at all. The first step, Elise, go ahead. The first step is to find this arc. Like that's kind of our first goal because this angle opens up towards the arc, which is what you were going for, right? And you said, well, if I look at this piece and then I find this piece, I can add them together and then I would do something with it. There is a slightly easier way to find that arc. We can find the entire arc together, not piece by piece. Is that where you're going? Okay. Ideas. Go ahead.
74 plus 80.
You get 156. 360 subtract the 156 is 204. So this entire arc right here, 204. Now how does this angle, somebody new, thank you Susanna, how does that angle relate to the 204? That angle is going to be half of it, right? So if this is 204, did I subtract that right? This is 204, this guy has got to be what? Oh wait, hold on, this isn't 156, it's 154. So this is 206. So this is, it looks a little bit off, 103. Questions with that one? Okay, now try part E. Maybe it's not a lot harder. It's actually a little bit easier than I was thinking. What do you do with the 85? Braden, will you start us on this one? By the way, in the last one, if you volunteered, you get 2 points. If you got the 103, you get the other point. Good. So our first goal is to get this arc. And so you take the 85, double it, we get what? 292, 360 minus that is 68. Okay, so this arc must be 68. P.S. I was warned about your secondary 3 class next year. Apparently there's a lot of friends in that class today. Mary, hi. How are you? Okay, last one, part F. 30 seconds, go. I'm good with wild guesses. As soon as you're done with part F, go ahead and get out your homework and get started. This is the end of our recording. I'm just going to come around person by person to make sure you've got it. So thanks for watching. Peace out.